So today on our tour for the three collisions, first we will start out with the Andes Mountains, which is caused by an oceanic continental collision. So we're just going to go to South America. So about right here we have the Andes mountain range. Maybe. So South America is a continental plate and has a low density. The Nazca Plate is an oceanic plate that lies to the west of South America. The Nazca Plate is slowly moving east as South America is slowly moving west. The collision of the two plates is called a subduction zone. At a subduction zone, the heavier plate, the Nazca Plate, dives below the less denser plate, South American Plate. There is also some volcanic activity in the Andes. There are 180 active volcanoes. And as the oceanic plate moves under the continental plate, it is heated and melted, which causes the volcanoes to be created. So, the denser oceanic crust subducts underneath the continental crust. And the mountain ranges form on the land, and the nearby oceanic trenches form in a subduction zone. And you can kind of see this little line right here, looks like it's popping out. That is where the ocean trench is. And as subductions increase, earthquakes are more numerous and powerful. So some more earthquakes can happen along here. So here we have the Andes Mountain covering almost all of the west part of South America. Alright, so the next one we will go to is the Altoland Islands of Alaska. So the Altoland Islands are kind of right in this range. Right here, it's kind of the mountains. The Aleutian Islands were formed by the North American and Pacific Plate colliding. Mount Cleveland is one of the most active volcanoes in the Aleutian Island arc. So we'll just look that up real quick. Cleveland, Alaska. So Mount Cleveland is going to be right there. How it was formed is the end of the North American plate is a little bit on the ocean, and then obviously there's the Pacific plate, which is also an ocean. So the North American plate was moving in a southerly direction as the Pacific plate moves northwest. Since the Pacific plate is denser, it moves under the North American plate, causing this island arc and causing this volcano. So the older, denser plate subducts below the younger one. Therefore, the Pacific plate is older, so it will go under the younger North American plate. Volcanoes often form, which as we can see, there's the Cleveland volcanoes, and then many of these other ones along here are active volcanoes. Some of them are active, some of them are not. And large earthquakes are normally found in these subduction zones, which causes the volcano to erupt sometimes. And then the last stop on our tour is going to be Mount Everest and the Himalayan mountains. So we're just going to go right over here. Alright, there we go. So here we have India, and then there's Asia. So the Indian tectonic plate was moving northward as the Asian plate was moving just a little bit southward. This is a continental-continental collision. Since the continents are of about the same density, there isn't much buoyant for this subduction, but however, they do kind of submerge under, so the denser one will go under the less denser one just a little bit, causing that mountain range to form. And so this was cause of the largest mountain range in the world to form. And volcanism is very rare in a continental-continental collision because there isn't really any hot spots under these continents. So that is how we get the mountain range to develop. So here we have the Himalayan mountain range. It's about right along here. And then the top, the highest peak Mount Everest is about right here. We'll just zoom out a little bit. So Mount Everest is a little bit towards the eastern side of the mountain range, but also in the middle, just kind of depending on how you look at it. All right, and that is about all we have. So in this chapter, we learned about the collisions, and we just talked about a continental collision with Asia and India. We had a oceanic continental collision here with the Andes Mountains in South America. Then up in North America, we had the oceanic continental collision.